Hi all, welcome to Any Too Many Networks. So let's talk about the part 3 of DHCP that we were talking about. So far we have finished part 1 and part 2. Please do watch part 1 and part 2 of this DHCP if you guys are not able to, get the video. So please complete those 2 videos and then come to part 3, because here what I'm going to talk about is we have showed how to configure router as a DHCP server and how to configure a DHCP server, separate DHCP server in a different network, and then how we can actually able to get IP addresses for the clients from the DHCP server. So let me walk through what is the packet walk. Okay, so if you are configuring DHCP, so what are the ports that they are using, and what could be the source IP address when it does not have any IP address at the starting of the stage, when it does not have any IP address, and what are the messages that it's gonna send. People will talk about, everyone talk about DHCP DORA process: discover, offer, request, and acknowledgement. So let me show you like what are those exactly, and what are the fields available in all those. And let's go ahead and watch. So let me show you the Cisco packet tracer again, and over there I'm going to show you exactly. So this is again when your router is acting as a DHCP server. I have already set up the configuration. If you don't know how to configure, you can actually watch my part 1 in order to see. So right now, let's go ahead and see, does my PC has any IP? Okay. So if you give IP config, just there is no IP, right? You can just see there is no IP right now. So what I'm gonna do is, since everything is all set, so I'm gonna request IP address from the DHCP server, in which in this case my router is acting as a DHCP server, as you all know. So what I'm gonna do is, let me start a packet simulation. So here I'm gonna start. So now I will request for the IP config / renew. So this is like requesting an IP address. So the first step you all know is discover, DORA process, right? Discover. So let's go ahead and see what is discover packet. So I will click on IP config / renew here, and then let's go ahead and see what is the first packet that this PC will construct. So you can see this type of the packet is DHCP. So let's open and see what is the DHCP packet here. You can see that DHCP packet server 0.0.0, because so if you open this, if you go and see the DHCP field, the client address is 0.0.0 and the server address is 0.0.0, because it doesn't know which one is the exact DHCP server in the network. So first it will be all 0.0.0.0. Okay, in the DHCP field. Okay, and as you all know, so that PC will have a MAC address, so that MAC address will be available here. And the main thing that you should be observing here is that the ports, UDP ports. So the source port is 68 and the destination port is 67. This is the server port and this is the client port. So these are the 2 ports that you will be using for DHCP protocol. And in the IP layer, you can see it doesn't know what is the IP address for that PC. So that's why it is using 0.0.0.0, and the destination IP would be the broadcast. So it has to send it to everyone in the network. So it's basically requesting that who is the server, who is the DHCP server. That's why it is 255.255.255.255. The same thing in Ethernet also, it will be all Fs, because it does not know the destination address, MAC address, but it knows the source MAC address. So that's why it puts source MAC address of that PC. So this is what I was talking about. I'm going to show you the packet. So let's go ahead and click on the next step. So it has sent out, since it's a broadcast packet, it has sent to everyone. So now you can see it is sending an ARP. This is called gratuitous ARP request. Why it is sending is because so this server wants to offer 0.11. 0.11 is the IP that DHCP server wants to offer to the PC. You can see here. This is the source IP, the server's IP. The target IP is this, and since it's an ARP packet, you will be only able to see this. So this ARP is sending to actually resolve. Is there any like 192.168.0.11? This is a gratuitous ARP request for which there will not be any reply. So that's why the reply is like you can see. So it is trying. So it constructed a DHCP so offer. You can see offer here. If you go here. This is inbound, right? So this is the packet that it has received. So let's go ahead and see the next step. Yeah, it is sending an ARP because it is checking is there any IP address with 192.168.0.11. See, this is the thing. So 0.11, it is checking is there 0.11 in the network. If there is no 0.11 in the network, it is going to offer this IP address. That's why their ARP packet is sending in the network. So there should not be any ARP reply. See, you will see the cross mark here. Yeah. So there is no ARP reply for that ARP request, because if there is any ARP request reply for that packet, that means that 0.11 is in the network. So it will assign some other IP address. Okay. So let's go ahead with the next step. You can see that outbound details 0.11. Not this one. So yeah, this is the DHCP offer. So let's go ahead and click on the next and let's see here. So this is the IP address, right? So it's gonna accept. It's not gonna accept right now. You can see that inbound details, it's if you go here, it is offering, it's you will be able to see here in DHCP. Yeah, your client address. It is offering 192.160.0.11. And the server address is 0.1. So this is the IP address that I'm going to give you. So it is offering. Okay. And you will have a transaction identity that you don't have to care. Again, yeah, source port is 67 and destination port is 68. And again, if you see, this is again a broadcast. The source IP is there, but the offer is also a broadcast packet. So that is what the main thing that you have to concentrate here. The destination IP is a broadcast address. So it is again, the offer is also a broadcast. So now it has received. So now it's going to construct a DHCP request to the DHCP server saying that, hey, I want to have this IP address. So you can see it is sending a request packet. Again, as I said, the request packet is again a broadcast. That's why you have seen two packets going from here. So this packet is again a broadcast packet. So you can see that inbound details, right? So see, destination IP is 255.255.255. Since again, the source IP is again 0.0.0.0 because it hasn't received any IP address. It did not take IP address yet. So it is still there. So now it's going to send an acknowledgement that again, it is going to be a broadcast. You can see that. Yeah. So it has received. Now you can see the tick mark here. It has accepted that IP. Again, you can check. This is again a broadcast. See this destination IP is broadcast IP. So again, you can see this offered IP address 0.11. So again, after all this, you have seen a ARP packet here. You can see this is ARP. Why this ARP packet? Before accepting a IP address for this PC, it is going to check, is there any, before accepting that IP address for this PC, is there any a PC or is there any host in the network which has the same IP address? It is going to check an ARP. If it gets a reply, I mean ARP reply, that means there is a guy who is having this IP address. If it doesn't, then that means there is no IP. I mean, there is no guy who is having the same IP address. That's when this PC will accept. That's why you can see an ARP packet is constructed here and it's going to send to everyone. As you know, ARP is always the broadcast. So it's going to send to everyone. You can see the wrong mark here, the cross mark. So this means that 0.11 IP address is not taken by anyone. So that is free. So this PC can take that 0.11 IP address. So this is what the packet walk that I want to show you. All the DORA process, discover, offer, request, and acknowledgement, all the packets are broadcast packets. And at the end of the, like once it receives the acknowledgement, it's going to send a gratuitous ARP request for which there should not be any reply, ARP reply. If there is no ARP reply, that means there is no guy who is having that same IP address. Then this PC can accept that IP address. So this is the process of how a client gets an IP address from the DHCP server, and this is the packet walk, and these are the messages that I want to show. In some cases, like if you actually use a Wireshark, you can actually see that the type of the message can be unicast in some time, in which case like there are two cases where you can see sometimes offer and acknowledgement can be sometimes unicast. In the other in all the like in different cases, you cannot see that other messages as broadcast, not a broadcast. Okay, you can see that. So I think that's it. It got the IP address. Now you can check here. It is received 0.11, right? We have issued a command IP config/renew. Now all the process is completed. Now it has got 0.11 as an IP address. This is what I was talking about. So this is how any PC will get a packet, an IP address from the DHCP server. So this is the packet flow. I think that's all I have. Thank you.